Hello, Year 10s. It's Miss Bishop again. How are you doing? Today we're going to be looking at uh, river management, so how we can control flooding, so hard and soft engineering strategies. This should really be the end of the rivers unit, and then we're going to move on to something a bit more interesting. So what we're going to do today is we're going to have a look at the different strategies, going through them, looking at the positives and the negatives. And then you will just answer a question at the end. I hope you are all okay and you are ready to rock and roll. So, let me get rid of this. So you're going to need to draw a table out today. So if you could get a pencil, pen, some paper. If you've got a printer, you can print the attached document. I will attach it to class charts. So if you do want to print it off, that's fine. If you don't have a printer, just copy it out or make your own kind of simplified version if you want. Okay. So we're going to be recapping the costs and benefits of managing river flooding through hard or soft engineering. This will help us deepen our knowledge of rivers. That's why we looked last week at what did we do last week? Oxbow lakes, waterfalls, meanders, levees, floodplains. It's just to deepen that knowledge, because really we're not now going to get a chance to go over this stuff again before you sit your GCSEs. Okay, so this is the worksheet. So if you have got a printer, print it off. Brilliant. If you haven't, just copy one up. Okay. And we're going to go through each of the methods. So hard engineering it usually involves a structure. Okay, so you are almost stopping the flooding from happening. They're usually expensive. It's the same with the coasts, with the sea walls and like the riprap and stuff like that, the rock armour. It's usually quite expensive. So you will get under this categories. You'll get dams, which will then have a reservoir behind it. You will have embankments, which are kind of like those man-made levees that I spoke about last week, but if you call them embankments, then you won't get confused. We also have channel straightening, because if you've got lots of meanders in your river, you have more water flowing because you have a longer route, so you have more chance of flooding. So if you make the channel straighter, you've got less area that the river could flood. And flood relief channels, which is just an extra river here, which just takes some of that flow of water. So it just almost acts like a diversion to allow that extra water from the rain or wherever to flow through to stop the main river from flooding. So, unfortunately, I've picked a case study that's got a very difficult name. So this reservoir, Clywydog, it's not Clywydog. I don't know. I don't speak Welsh. I can't pronounce Welsh words. So if anybody does know how to pronounce this, please let me know. It was built in the 1960s to help prevent flooding in the River Severn. Now, the River Severn is the river that flows in between Wales and England. Has its mouth at like Bristol area. These block, get rid of that, go away. These dams block Slow River, and then you can allow water through. And behind it, because you've got a backlog of water, that will then become a reservoir. You can set the amount of water that you want to be released from the dam, and you can then use that energy with to create like hydroelectric power, because you can use that water to spin the turbines to create power. Okay, so they're widely used around the world. I mean, there's some that are absolutely humongous, and some of them can cost up to £1 billion. They're very effective, especially during periods of high rainfall, because they have that reservoir behind them collecting up the water. You do have to potentially, where you would have had originally a river behind this dam, this might have been a small village around here, so you will have to flood certain areas. I know Buellwater, there used to be a village, or certainly some houses underneath that, and they had to flood it. So they would cost a lot of money, because also you would have to then pay off the people whose homes were potentially being flooded. Why we give case studies, it's always good to use case studies. It shows a higher level of knowledge. You can certainly use an easier one than the one that I've picked. You could pick like the Hoover Dam in America or something like that. There's plenty of dams all around the world. Some are harnessing energy from great rivers around the world. So have a look, have a little bit of research. This is your chance to personalize your revision to whatever you want to do. So they are expensive. Okay, so in here, you've got dams and reservoirs, so we're going to be writing about them. So you need to write that they are expensive, but they stop the flow of water, and you can use it to create energy. We've also got here channel straightening, which cuts through meanders to create a straighter channel. The only problem with this is if you are digging through rivers, you're obviously going to have animals creating homes along the sides of the riverbanks. Rivers are rich with life, aquatic and land animals. You might have some ducks there. You've got fish. You might have some like frog spawn. So that's the problem that you do have, is that it can affect those animals that live there. The only problem is the area where the channel straightening is. It just means that there's less area, because if you've got a meander, if you straighten out those meanders, that might be 10 miles long, but if you then cut a straight line through that river, it might only be a mile long. So you are losing all of that potential water that could flood the area. The only problem is that because it will flow faster through that area, because it doesn't have to wind through all of those meanders, all of that water has got to go somewhere. So as soon as that that channel straightening stops, you're going to get flooding further downstream. Sometimes they are lined with concrete, but that really does then affect sort of the natural life. It does mean that the rivers don't need dredging, so it is good in that respect. However, a concrete lined river really is not attractive, and it won't look very nice. It's very expensive as well. You've got there £4,700 pounds per metre. Now, if you're doing several miles, say you're doing sort of a 3-mile stretch of a river, that's going to be, well, let's do it in kilometres then, because it'll be easier. It'll be 3,000 kilometres. Metres in a kilometre. It's late. Ignore me. You've got to then times that by however many. It's going to be several £1 million. So it is quite costly in the grand scheme of things. Next up, we have embankments. So these are those kind of man-made levees that I spoke about last lesson, which were sort of natural ones. You can get these concrete man-made ones. 4,700. Sorry, I'm just So according to my C grade GCSE maths, okay, which I took 16 years ago, if you were to do a 3-kilometre river straightening, channel straightening, it would cost you 14 million. That's quite a lot. That is an awful lot. Anyway, I digress. Back to the embankments. So embankment is raised riverbank, sorry. So if you are raising up the side of the river, as you can see, let me get my mouse, if you can see here, so the bottom of the river is there. By raising it up on a slope means that that river, whereas before it would have flooded if it got to say here, but because of this bank going all the way up here, that river's got to rise up a considerable amount before it then floods the whatever's the other side of that, the road or a housing estate or whatever's the other side of that wall. So it is very good at protecting towns, cities. The Mississippi has got very large embankments, especially protecting cities like New Orleans and places like that. Sometimes it's got here that mud can be dredged, so you are using that natural material that would have happened when it flooded anyway, and you can just dredge it out from the side and push it up. That looks more natural than having sort of concrete or blocks or anything that's kind of man-made looking. It just doesn't look as nice. If this not maintained, then you could potentially have a case of not like a landslide, but it could then collapse and fall back into the river, which could then allow flooding to happen, especially if that then means that there's access for the river to move into the town or the city that it's protecting. This is 1,152 a metre, but I'm sure if you were to just dredge, it would be a lot cheaper. Because you're using materials that are already there. You're not having to get man-made materials shipped in from somewhere. And finally, a flood relief channel. These are man-made river channels, so almost akin to a canal, which is obviously man-made. These can bypass towns, cities, to stop them potentially being flooded. So they won't have anything in them during normal times. It will just have a low level of water in it, like you can see at the top here. And then when it is flooding or potentially could flood, they will then open up those gates and it will just then allow that excess water to flow through. So you can see here we've got the Jubilee River at Maidenhead. It just stops. If the Thames was to flood, it would potentially flood Windsor, Eton, those sort of quite important areas. But if it was to flood, they could open up this Jubilee River channel here, and that would then take the burden off of the River Thames, which would then mean that it wouldn't flood. It's had a positive impact on the environment, because if you're creating, another water channel, you are going to have animals inhabit it. Yes, it is a canal, and yes, it is, going to be not very attractive, but you're going to have fish breeding there. You're going to have ducks there. You're going to have other, animals and wildlife starting to inhabit it. So it is going to be environmentally very useful. These are £12,000 a metre. Blimey. So, me and my calculator. So we're going to have 12,000 times 11,000. Really? Oh my Lord. So that Jubilee River, according to me, please do tell me if I'm wrong with this. So that 11 kilometres at 12 at 12,000 a metre, times that by 11,000 is 132 million pounds. 132 million pounds to build that. Blimey. Well, I hope it's worth it. I hope it's worth it. So very, very, very expensive. I'm shocked at the price of that. I mean, I know sea walls are expensive, but what? What? That's extortionate. Absolutely extortionate. Right. So you should have filled out this. So you should have filled out all of this bits here. Okay. Just put some information down. Case study names, what they do. Let's move on to soft engineering. So soft engineering is exactly the same as with coast. So it involves using natural processes. So you are not building a structure per se, like a physical structure. Okay. We've got sort of 4 types of soft engineering. We've got afforestation, which is planting trees, floodplain zoning, wetlands, and river restoration. So we're going to go through these exactly the same as what we did with the hard engineering. These prices look a bit better, don't they? Very much so. So, afforestation is planting trees. So, if you have trees, lots of trees, they're going to need lots of water. So, in theory, when it rains, that water will find its way into a river. But if you've got trees in the way, those trees are going to intercept that water. So before it reaches the river, those trees are going to be like drinky, absorb it all, and then less is going to flow into the river. So planting trees is a very, very good way of, 1, counteracting climate change, and 2, stopping flooding. Okay, it's very good. And there is obviously some initial cost of planting trees because you've got to dig a lot of holes in the ground to plant those trees. It's a lot. It takes it's hard work. And then once they're established, you've then got the whole sort of environmental positives. I mean, the positives of planting trees it's a very, very, very good method. Very good method. I like trees. They're very nice to look at. They're very nice to climb. They're lots of fun. So what's not to love? 864. What /K means? What was? Oh, maybe per 1,000 trees? I don't know. I'll find out what I mean by that. I borrowed this lesson from Mr. Joy, so I'll find out what he meant. Wetlands. Wetlands are areas that are allowed to deliberately flood. So you might have an area that has been bought off, and when it floods, this area there's nothing there that's important. There's just fields and hedgerows and places like that. And they just are allowed to flood, and you are going to get so many different birds, plants growing there. You're going to have ducks, swans, geese. There's some herons in Robertsbridge, where I live. We've got some herons knocking around. I've never seen a real life heron, but it's absolutely amazing. It was huge, this heron. That's living near rivers and near water, so you'll see all of those. And also, rumour has it there is a kingfisher as well around these parts. Beautiful birds. it just means then that that water can just sit there and be stored there. I don't know if you guys ever kind of go up the A21. You might do. So when you go past Blackbrooks and Settlescombe, turn off, you have that long straight bit of road. And after it's rained, those fields always flood. Always flood. Um, it's not the same as a wetland because that those fields shouldn't flood, but it's that same kind of concept where they just allow that water to just slowly drain away. If the rock underneath it is impermeable, then it might just sit there for a while. So that water can then just kind of slowly seep back into the kind of water cycle. So it doesn't matter if it does flood because it's not being used for anything. So these, in theory, don't cost anything. Farmers can use it if they've got a river flowing through a lot of their land. They might want to sacrifice some of their fields so that further down, where the grass is more lush, they've got their cows out to pasture and they can eat the fresher grass, whereas they might have not nice fields further upstream. Um, you know, it's just it's an easy way to help flooding. Floodplain zoning. Now, this in theory costs nothing. However, this needs to be done before, like, when you're building a new area, okay? Because obviously you can't do it on somewhere that's been around for several hundred years, if that makes sense. So areas that are closest to the river, you would use like fields, and where animals graze, playing fields, that type of thing. You would have those areas closest to the river because if they get flooded, it's a bummer, but it's not a big deal. If the playing field gets flooded, you can't play football for a couple of months, but it's not the end of the world. Then on the next kind of level, the next level up, you would build your roads and your car parks because, again, if that flooded, yes, if there was a car left there after a flood warning, yeah, that would get ruined. But ultimately, it's a car park, so unless people move their cars, not a lot would happen to it. You would then put your industry and your housing in the higher up levels because they are less likely to flood. Because if you think down here, if that river is going to flood all the way up here, where you'd have had a tsunami or something, because it's not going to flood. So the issue that we've got is places that are very, very old, like where I am. I know I waffle on about it being in the valley and being in a floodplain, but essentially where they've built my village 1,000 years ago, it's all the way down here. So that's why everyone's houses flood. I mean, I'm sort of like here, so we're okay. But literally, some villages are right next to the river because that's how people used to build. Whereas if you were to build a newer town, as there's lots of new out of city housing estates and sort of like Milton Keynes type areas that are really new, you could use this concept on those where you would put all of the recreational bits and bobs, the farming aspect, and then put your housing where people's expensive belongings are, high up, so they're right out of the way of the flood. There are issues. It says down the bottom here that with current housing shortages, you really can't be choosy. But as I always say, it's better to, not have a house on a floodplain where it's going to flood, you know? So, I don't know. Take it as you will. So, it's good when you've got new building, but if you've already got an established place, it's not going to work as well because you can't move millions of pounds worth of houses halfway up a hill. It's just not going to work. So it only really works on new buildings. And finally, we have got here river restoration. Now, river restoration is about allowing those rivers to start to meander again. So it kind of, they need to kind of almost rip up what they had done. So it's almost really like they're counteracting the channel straightening. So if they have done a channel straightening to divert a river, like they've done here, they've then reinstated this curved river and allowed this to dry up. It slows it down, so it stops it flooding downstream. And also, if you are digging up the bottom of a river and getting rid of all of that sediment, you're opening up the river channel a lot more, making it a lot deeper, so it can hold a lot more water. And it just allows nature then to take over. So nature knows best, and as long as you're restoring those river channels to allow the water to flow through, and you're just making sure that those river channels are as clean and as deep as they possibly can, it's only going to do wonders. That costs 1,509 approximately. That's a very specific number per metre. So again, it's not a cheap option, but really, the cost of building flood defences is less than the money that could potentially be spent on insurance payouts if a whole village flooded. You have to kind of look at it like that. You can also do preparation as well. So you do have satellites going around, and you will have sensors and things like that. I know on our flood defences we have like the Environment Agency that come out and check them very often, and if we are due to have a flood warning like we had a few months ago when the river flooded before we went into lockdown, we did have the Environment Agency out because they are the ones then that can release the floodgates if need be. You also have weather warnings on the news, and they will do those locally as well. Some areas, some countries will have a text message system, so it'll be a public service announcement. Some areas might have oh, my cat's just come to say hello. Hello, boy. He's a good boy. Oh, sorry, he's so cute. You might have a like an alarm, almost like a siren. So if it is due to flood, it will then alert people to move to higher ground. So there are 3 levels of flood warning. Flood watch, which just means that you're going to get low-lying land and roads are expected to flood. You have a flood warning, which means that homes and businesses could potentially flood. And then you've got a severe flood warning, which means that life is at risk. Some people don't take these seriously, but having watched, you guys are well aware of the floodings that have happened recently, that people do die. You can get swept out, and you can die. You can get sucked out into the river, and yeah, it is a risk. It is a risk. So you take it as you want. If you don't want to take that information seriously, you could potentially lose your life. Or if you want to, it might be an overreaction, but you can always then come back home. It's better to overreact in some respects than underreact and suffer in the long run. So, what does the Environment Agency do to help? Well, the Environment Agency plan. So they provide a lot of the plans that then the government will distribute out. They come up with the cracking idea to move valuable items upstairs. Genius idea. Absolute genius. Whoever thought of that deserves a medal. Using floodgates to prevent floodwater from damaging property. You can get floodgates for your own house. We have floodgates in the village, blocks off the village entirely, so you cannot, if the floodgates are up, get into the village. You're essentially trapped. So that's the whole point of them. They can't be opening and closing them to let people through. And you can use sandbags. Back in the floods of, when was it? 2000, 2001. I was in year 8. Got pulled out of food tech. We were going to make a stir fry. I remember it so clearly. I was halfway through my stir fry. And I got pulled out of school because I had to go and help put sandbags outside my grandma's hairdressers in the village because it was too much hard work for the others. So sandbags do work because her property did not get flooded. And that was like 20 years ago now. Was it? 20 years ago. Yeah, it would have been. So sandbags are very efficient as well. So planning, moving your stuff upstairs, it's always worth it. You might want to move your TV up and your sofa upstairs if you can wedge it upstairs. And any valuables, any, Van Gogh paintings you got knocking around, or your grand piano. I don't have any of those things, but some of you might. All of these things. So they will help to give you kind of a plan of action of what to do. And they will be the ones that maintain a lot of the flood defences around the area. So what I want you to do is to have a go at answering this question. Explain how flooding can be managed using hard engineering strategies. So explain means that you have got to give reasons. So give your reasons on how hard engineering can protect from flooding. Okay, it's 6 marks, so I'm going to need several points really expanded upon. Okay, so have a go at answering that question. I am going to put the mark scheme up underneath in a second, so pause it now if you don't want the mark scheme up, and then I will put the mark scheme up and carry on. So for a basic answer, you're going to describe 1 or 2 hard engineering strategies. A little bit of explanation. Tentative means you've given it a go, but it's not really been excellent. Statements may be random or separate, so you're not really making a lot of sense. You're just writing whatever comes, whatever you're thinking goes straight onto your paper. You haven't really thought about it. For a level 2, you need to give descriptions of 2 or more hard engineering strategies. Clear explanation. So you have linked them, they have developed, so you've given points, and there is an example of an answer that you could use. So have a go at marking your work. If you want me to have a look, please do. But if not, I will see you next week, and I think we will start doing hazards. Okay, I'll see you later. Bye.